Hey guys, this is the lecture for section 3.3. Section 3.3 really doesn't have a lot of notes, so I'm just going to work a lot of examples. Chapter 3.3 is over dividing polynomials. And so the first way that we are going to talk about it is using long division. Long division with polynomials is the same as long division with numbers. Maybe you don't remember long division, but long division was where we take like 725 and we divide it by 5, and we'd ask how many times does 5 go into 7? 1, and you subtract and you get 2, and then you bring down 2. How many times does 5 go into 22? And you'd say 4, you get 20, again subtract, and then you bring down your 5. How many times does 5 go into 25? You'd say 5. So 725 divided by 5 is 415. That's long division using numbers. You can do the exact same thing using polynomials, and it's the exact same method. So for our first one, we have x squared plus 10x plus 21, and we're going to divide that by x plus 3. So what we do, that x plus 3 is what's going to come out front. So that's what we are dividing by. And then this polynomial is what goes underneath, our x squared plus 10x plus 21. Just like over here, I asked how many times does 5 go into 7? I'm going to look at my first number or my first variable, and I'm going to say how many times does x go into x squared? X goes into x squared x times. So I'm going to write that over here above my x's. X times x gives me x squared. X times the positive 3 gives me positive 3x. Okay? Now here's the thing. When you draw your line, as I say, you change your signs because you're subtracting. We're doing that in order to get rid of our x squareds, which those go away. So we have 10x minus 3x, which is 7x, and now I'm going to bring down my 21. Again, I'm going to ask, how many times does x go into 7x? Well, we'd say 7 times. So plus 7. 7 times x is 7x. 7 times 3 is 21. Again, we draw our line, we change our signs, and I'm left with 0. So up here is my answer. I guess I'll do that in my colored chalk. I don't know if the colored chalk shows up on the video or not very well, but x squared plus 10x plus 21 divided by x plus 3 is x plus 7. Let's move down. We'll do another one. We have x squared plus 14x plus 45 divided by x plus 9. Again, the x plus 9 goes on the outside. X squared plus 14x plus 45 goes underneath. How many times does x go into x squared? X times. So x times x is x squared. X times 9 is 9x. Draw my line, change my signs. That way my x squareds go away. 14 minus 9 is 5x, and then I bring down my 45. X goes into 5x 5 times. So 5 times x is 5x. 5 times 9 is 45. Draw my line, change my signs, everything goes away, and I get 0. So x plus 5 is my answer. Now, so far, we haven't had any remainders. We've had 0 at the end. So what happens when we do have a remainder if we are doing long division? Pretty much the same thing that happens whenever, sorry, I'm trying to find a nice spot to put my laptop. It's a little slanted. Sorry. Pretty much the same thing that happens though whenever we information. Yeah. Sorry, guys. There we go. That's better. If you get a remainder, you're going to put whatever the remainder is over whatever you're dividing by. And so that kind of gives you a hint that this one's going to have a remainder. So again, I've already written it out in the division form for long division. So we're looking at 3x into 6x cubed. Well, 3 goes into 6 2 times, and x goes into x cubed x squared times. Because remember, we're trying to get rid of that first thing. So that will give us 6x cubed, and then 2x squared times a negative 2 will be a minus 4x squared. I draw my line, I change my signs. That will allow this to go away. Negative x squared plus 4x is a 3x squared. And then I bring down my minus 5x. 3x goes into 3x squared x times. So plus x on top, and I get 3x squared minus 2x. I draw my line, change my signs. Negative 5x plus 2x is a negative 3x. And then I bring down my plus 4. 3x can go into negative 3x how many times? Well, a minus 1 time. So if I take minus 1 times this, it's going to give me the negative 3x that I need. And negative 1 times a negative 2 becomes a positive 2. Draw my line, change my signs. So my 3x's go away. 4 minus 2 is 2. So I have a remainder. I can't take 3x times anything to give me the 2. So I stick the 2. I put plus 2 all over 3x minus 2 at the end. So I have 2x squared plus x minus 1 plus 2 over 3x minus 2. We do that with regular numbers as well. Let's say 16 divided by 3. Okay, so 3 goes into 16 how many times? 5. We get 15 with 1, 15 and 1/3 left over. So we do it with polynomials just the same as we do with regular numbers. I'm going to move all the way to the back of the room. I'm so sorry. You're going to have to look at me for just a second. Because there's another case that happens where we're missing some numbers. So we're going to have to put some placeholders in. And that's not a big deal. It doesn't make our problem any harder. But here we have 6x to the 4th plus 5x to the 3rd plus 3x minus 5. So notice we don't have an x squared number or element in this case. So when we write this out, we need to put a 0 there as a placeholder. That's really the same thing as even writing the number 105. We don't just write the number 15, we have to put a 0 there for our tens place. And so that's kind of what we're doing with our polynomials. So we are dividing by 3x squared minus 2x. And what are we dividing? We're dividing 6x to the 4th plus 5x to the 3rd plus, now here's where our x squared number or unit would be, but we don't have one. So I'm going to put 0 x squared, and then I do have a regular x minus 5. So it gets kind of long, but you need to make sure you represent each and every number or place value in your polynomial expression. And so if you have to put in zeros, you might have to do that. Okay, so I'm looking at 3x squared into 6x to the 4th. Well, 3 goes into 6 2 times. X squared goes into x to the 4th. I'll need an x squared. Notice when I write my answers on top, I put them underneath the placeholder on bottom. That's just an organizational system. It helps it to stay in place. So that's going to give me 6x to the fourth, and then 2 times a negative 2 is a negative 4x to the third. I draw my line. I change my signs so that my leading one goes away. 5 plus 4 is 9x to the third. And then I bring down my 0x squared. So 3x squared goes into 9x to the third. 3x times 3 times 3 gives me 9. X squared times x gives me x to the third. So that'll give me 9x to the third. Negative 2x times a 3x will give me minus 6x squared. I draw the line, change my signs. That goes away. 6x squared. I'm going to bring down my plus 3x. 3x squared goes into 6x squared 2 times, which will give me 6x squared and negative 2x times 2 minus 4x. Draw my line, change my signs. 7x minus 5. Well, I have 3x squared, and I need it to look like 7x. That's not going to happen. You also can kind of know that's not going to happen because my last one was just a constant value. So that means my next thing should be my remainder. And that is true. So I'm going to take this plus 7x minus 5, and I'm going to stick that all over the 3x squared minus 2x. And so all of this is my answer. 2x squared plus 3x plus 2 plus 7x minus 5 all over 3x squared minus 2x. So this one was different from the other ones because we had to put the placeholder in. Okay, so let's do another one. And then I'll teach you a new way to do division. Although it shouldn't be new, you probably have seen it. It just may have been a hot minute since you've done it. Okay, this one, we have x to the third plus 4x squared minus 5x plus 5. So this one, I don't need a placeholder. Everything is totally okay. So I have x minus 3. And I'm dividing x to the third plus 4x squared minus 5x plus 5. So I need x to go into x to the third. So I need x squared. That'll give me x to the third minus 3x squared. Draw the line, change my signs. So I get 7x squared. Bring down my negative 5x. I need x to go into 7x squared. I need a plus 7x, which will give me 7x squared minus 21x. Oops. Not that it really matters. Draw my lines, change my signs. So I have 16x. I need to bring down my plus 5. So x needs to go into 16x. That'll be plus 16. 16x minus 48. Draw my line, change my signs, and I get 53. That's going to be my remainder, so I have to stick that at the end, plus 53 all over x minus 3. Stick it over what I'm dividing by. So far, all we've done is long division. But there is kind of a shorthand way of doing division with polynomials, and it's called synthetic division. So the first synthetic problem that I'm going to do is doing the exact same problem we just did with synthetic division so that you can see that we get the right answer or that the answers are the same. So with synthetic division, what we do is we write the leading coefficients. Okay? So my coefficient for this x is a 1. My coefficient here is a 4. And then a -5 and a 5. Okay, so this looks kind of weird. I draw an arrow underneath my first one, and I draw a big line. And I bring that 1 down. Now up here, I have a little box. That's my division box, basically. And what am I dividing by? Well, I'm dividing by, what am I dividing by? By -3? By -3. Sorry, I left my notes up at the front, and now I'm starting to question what I did. Yeah, it's +3. Goes in that box. Sorry, not negative, it's a positive. Okay, so what in the world is going on? This is the setup for a synthetic division. You put the leading coefficients, and then you put the number here, that would be x minus whatever. So in this case, it was 3. Okay, so we bring down our 1. So for synthetic division, what you do is you multiply from what's in the box by what's on bottom, you put it here, and then you add. And then you do the same process again and again. So we brought down our 1. So 3 times 1 is 3. So I'm going to write that right here. Then I add down. That's 7. 3 times 7 is 21. Then I add down, which will give me 16. 3 times 16 is 48. I add down, which gives me 53. Now, what we did was we started with an x to the cubed, so we're going to end with x squared. So these are my coefficients now, starting with x squared. So I have x squared plus 7x plus 16 plus, and this last number is my remainder, 53 over the x minus 3, which, if you look, is exactly what we got when we did the long division. So we did it with long division and got x squared plus 7x plus 16 plus 53 over x minus 3. And we got the exact same answer here using synthetic division. Okay, synthetic division is really nice and really quick, and we're going to use it a lot moving forward in this class, but it might take a little bit to get used to it because we're kind of used to long division. We did that with numbers. Synthetic division is not something we've done with numbers, and so it's something completely unique. I'll do another one. Okay. This one is slightly different, not a whole lot, but if you look, we have 5x to the third plus x, or 6x plus 8 divided by x plus 2. Well, notice we're missing our x squared term. So just like with long division, we had to put a 0 in that place. We'll have to put a 0 in this place too. So out in my box over here, what am I dividing by? Well, it's a +2, so I'm dividing by -2. Okay, over on the first problem, it was x minus 3, and we just divided by +3, so you switch them. Okay, now I write my coefficients. I have a 5 for the x cubed, then I have a 0 for my x squared. I have a 6 for my x, and an 8 for my constant. I draw my arrow, and I write my 5 down first, because we don't change anything about that first one. 2 times -5 is -10. Then I add down. -2 times -10 is 20. And then I add down. -2 times a -20, or times a +26 2, 1 is a negative 52, which is a negative 44. 44? 44. Sorry, when I'm on the spot, for some reason I can't do basic math. So what does this mean? We started with x to the third. We're dividing by x. So we have 5x squared minus 10x plus 26 minus 44 over x plus 2. Again, you could check that by doing it with long division and making sure that you got it correct. The big thing with synthetic division is making sure you remember to flip the sign out here. And synthetic division only works if our leading constant here is a 1. We can't do this if it says 3x plus 2. So that has to be an x plus 2. Or an x plus whatever, or minus whatever. So you flip the sign and then you bring down the first number, you multiply and put that there and add down. Multiply, put it there, add down. That's really all there is to synthetic division. Like I said, we will do a lot of synthetic division coming up. But right now that's it. So that is chapter 3, section 3.